Here, amine chemistry. I like amines. You know what amine? Okay, so chapter 22, which deals with amines. Chapter 22 is kind of the last chapter that we do before we get into the biochemistry section. And I would almost describe this section as kind of a segue into biochem because there's so much amine chemistry and biochemistry. So for my students who will be taking biochemistry, there's a lot to learn in this chapter. So let's get into it. Introduction to amines. You remember when we talked about alcohols? We said that you can have a primary, a secondary, a tertiary alcohol. Well, you can also have primary and secondary and tertiary amines, but they're classified in a very different way than alcohols because the way that they're designated is by the R groups that are directly attached to the nitrogen. And they're all derivatives of ammonia. If you go right back to your general chemistry days, I know that everybody knows the structure of ammonia. Everybody knows NH3. So if you add one R group onto an ammonia molecule, you get a primary amine, you have two, you get a secondary amine, and if you have three R groups, then you get a tertiary amine. And of course, ammonia can participate in hydrogen bonding because it has a nitrogen-hydrogen bond right in it. And so can a primary amine, a pure sample, and so can a secondary amine. But if you have a pure sample of a tertiary amine, it cannot participate in hydrogen bonding because there's no hydrogen directly bound to this nitrogen. And that's something that we're going to come back to in a few minutes. I just wanted to throw that out there. So why is nitrogen chemistry so important to people who are interested in biochemistry and medicine? It's because nitrogen is ubiquitous in drugs, and whether they're legal drugs or illegal drugs. I mean, nitrogen is found everywhere in the pharmaceutical industry and in naturally occurring drugs as well. For example, morphine, you can see that morphine has a nitrogen in it, and we know that morphine is very commonly used as an analgesic in hospitals, people who are suffering. Cocaine, if you look at the structure of cocaine, it's actually not that complex of a molecule. It's got this bicycle here, and there's a nitrogen in the bicycle, and then it's got a methyl ester here and another ester over here. And then nicotine. If you've ever, known a friend who's maybe addicted to tobacco, well, nicotine has two nitrogens in it, so two heterocycles in it. It's got a pyridine in it and a pyrrole or a pyrrolidine in it. Anyhow, so we call these alkaloids. Any kind of naturally occurring compound that has nitrogen in it, we call it an alkaloid. Some other naturally occurring amines are interesting in neurochemistry. If anybody here is interested in the central nervous system and the chemistry of the central nervous system, here we have adrenaline, and adrenaline is what's responsible for the fight or flight response in us as human beings. Then you have noradrenaline and dopamine, and I'm sure you've all heard of dopamine before and how we release dopamine. It gives us a satisfied, sedated feeling. Too much, if you have too much or too little dopamine can cause depression, whereas too much dopamine can cause things like schizophrenia. But anyhow, the reason I put this compound down here is because students will ask about it all the time. And our textbook mentions this compound. So if you have an aromatic ring like this, okay, and then you have, just a nitrogen coming off of here and a methyl group down here. Stereochemistry, I'm not going to worry about that right now. But this is amphetamine here. And you can probably guess what this is. If we have a methyl group on the nitrogen, that's methylamphetamine or methamphetamine, which is also known as methadrine, and that is like what crystal meth is, okay? And one of the things that's interesting about crystal meth is that it could, people used to try to make it from ephedrine and pseudoephedrine, and then they come up with other derivatives of it to try to prevent people from making their own methamphetamine. Anyhow, that's a long conversation, but anyhow, now you know what the structure of methamphetamine is, and you see how it comes from amphetamine, and you can see how it's closely related to these other neurotransmitters on here. So anyhow, let's move on and talk a little bit more about the chemistry of amines. And what's interesting is that the trigonal pyramidal nitrogen of an amine carries a partial negative charge on its lone pair, and therefore it can function as a base or a nucleophile, right? If you draw the molecular geometry of an amine, we have 1, 2, 3 R groups, right? So if we draw the 3 R groups like this, I'm just going to draw the lone pair, sticking up like this. So it's got 4 groups attached to it, a lone pair and 3 R groups. And that lone pair, again, can function as a base or a nucleophile depending on the situation. If you react it with an acid like HCl, well, then, of course, it's acting like a base, and it's essentially neutralizing the HCl here. And we end up with, this would be an alkyl ammonium chloride is what you would call this. So you could also call this an alkyl ammonium salt. And in the second, reaction here, it's just functioning as a nucleophile, right? This is our nucleophile. Here's our electrophile. And again, you're making an alkyl ammonium salt is what you're ending up with. So the amine, again, can act as a nucleophile or a base. That lone pair, very important. If you look at the electrostatic potential map of this molecule here, this is trimethylamine, you can see that all the electron density is at the center of the molecule on that nitrogen, which is more electronegative than any of the other elements that are in there. So I ended up skipping ahead here. Where the heck am I? Right there. Okay. So let's move ahead from section 21.1 and let's talk about naming amines. And there's a couple of ways that we can name amines. It says that IUPAC nomenclature has 2 different ways of doing it. We have a common way of naming them, and then we have the systematic name. They're both accepted by IUPAC. So number 1 way of doing it is name the alkyl group and then just put the suffix amine on the end. And that is a common way of naming them. So I'll put common right here. So if we have an ethyl group, you call it ethylamine. If you have an isopropyl group, you call it isopropylamine. If you have a cyclohexyl group, you call it cyclohexylamine. You can imagine that if you had, let's say, a tert-butyl group like this, so you would call this tert-butylamine, right? So on and so forth, methylamine, et cetera, et cetera. But there are systematic names for these compounds as well. So systematic names for these, and we'll come back to those in just a second. If you have a more complicated amine where you can't just identify an alkyl group immediately, in that case, we use an alkane amine as a way of naming it. So we name the alkane first, and then we put the amine at the end. That would be the same nomenclature that you were used to with alcohols, okay? The exact same thing. So what we do is we find the longest carbon chain that possesses the amino group on it. We want to give the amino group the lowest possible number. Then we list the substituents in alphabetical order. If there's chiral centers, of course, we identify those, and then we provide a locin for all of the substituents, and we list them, like I said, in alphabetical order, and that's really all there is to it. So here, since we have a heptane and it's got an amine on it, we use 2-heptaneamine as our parent. So just the exact same way that you named an alcohol. Now, I just want to back up for 1 second. If you wanted to name those compounds on the previous slide as alkane amines, the way you would do that for the first one, for ethylamine, is you would call that ethane amine, right? The longest carbon chain is 2 carbons, and that's an ethane, so you would call it ethane amine. This one, you have 2-propaneamine. The longest carbon chain is 3 carbons, so you'd call this 2-propaneamine. And then this one, you have cyclohexane, so it would just be cyclohexaneamine. Cyclohexaneamine. All right, either one is perfectly fine, but again, if you can't identify the alkyl group quickly, just use the systematic way of naming them. Don't worry about the common names. Common names are used for tiny amines, but it kind of really stops there. I wouldn't be able to name this, giving it a common name. I don't think anybody could. So let's see, what else? If we have an amine as a substituent, if you have any other functional group in your compound that has oxygen in it, it's always going to take precedence over something with a nitrogen. I put just a smattering of the order of precedence of the functional groups here, you see everything with an oxygen comes before the amine. Okay, so let's say and we run into all kinds of compounds in organic chemistry. They have oxygens and amines in them. So the amine is just listed as a substituent, and we call it an amino group, right? So we have 4-aminobutanol, right? We have 1, 2, 3, 4 carbons. So this is butanol, and then we have 4-aminobutanol. Then if you have benzoic acid, right, you have an amino group at the para position. So this is 1, 2, 3, 4. So you'd call it 4-aminobenzoic acid or para-aminobenzoic acid. Both are perfectly acceptable. Just remember, oxygen containing functional groups will have a higher priority than an amine will. Another way, or another time that we'll see amines in this class, and organic chemistry 1 as well, is when we're dealing with aniline, right? If you go all the way back to aromatic compounds, I said, what are some of the aromatic compounds you need to know? Benzoic acid, acetophenone, styrene, etc. But a big one that comes up a lot is aniline. So if I give you any aniline derivative, just name it as an aniline. And the carbon that has the nitrogen on it, that's always going to be number 1. So number 1, number 1, number 1. And then you just seek to give the next closest substituent the lowest possible number. So here we have 1, 2, 3. So 3-chloroaniline or metachloroaniline, either one's fine. Here we have 1, 2, 3, 4, 5. So we have 5 ethyl, 2 fluoroaniline. All right, so naming things as anilines. Now, so far, all we've covered, if you've been paying attention, I didn't bring it up, but the only thing that we've covered so far in the nomenclature are primary amines. Look, this slide was about primary. This slide was about primary. This one was only primary. And this one was only primary. If you're wondering, well, how do you name something like, what would happen if you had aniline? Let's just draw something like this. Let's say you had aniline, but then on the nitrogen, what if you had, a methyl and an ethyl group on it? How would you name that? It's a great question. Because naming secondary and tertiary amines is something new. We haven't named secondary and tertiary really much in this class. Okay, a little bit of amide nomenclature, I guess. But there's a few ways that you can name secondary and tertiary amines. Check it out. First one, it says, name the alkyl groups followed by amine suffix. Use di and tri if there's more than one group. Something that I don't have on here, but we'll put here. Name the alkyl groups. Let's put here. We'll put alphabetical order. Let's just write A to Z. So we'll say from A to Z. So alphabetical order. And then we just put the amine suffix. So look, here we have an ethyl, a methyl, and a propyl. What comes first? Ethyl, followed by methyl, followed by propyl. Here we have 2 ethyls, so it's just diethylamine. And then here we have 3 methyls, so it's just trimethylamine. Okay, so again, we're just identifying some little alkyl groups, and then we just list them in alphabetical order. If they appear more than once, we say di. If it's twice, tri. If it's 3 times. Now, what if you have something that's got a carbon chain that's a little more complex? Well, then, of course, it becomes a little bit more interesting. In that case, just like we did with amides, you use the prefix N before the name of the substituent. So this is an N-methyl. This is an N-ethyl. The longest carbon chain is all of this over here. So this is some kind of 3-hexane amine. You see that right here. We have a 3-hexane amine. But then we just list all the substituents. Look, we have a 2,2-dichloro. We have an N-methyl. We have an N-ethyl. What comes first? The chloro is going to be first. The ethyl is going to be second. And the methyl is going to be third. And of course, there's a stereocenter here. So we have to provide that information as well. Now, it might seem daunting to look at all this and be like, oh, darn, more things to learn. But just like any nomenclature that you've ever tackled in this class, and this is some of the last nomenclature that we actually look at in the entire course, except for a little tiny smattering moving forward, the best way to master this is to practice it. So let's say we wanted to name these amines here, okay? And some of them, I'd say we could give common names to, really either. The first one, we could give a common name to it, no problem. And the second one, we could give systematic names. But I would say just by looking at these quickly, I would not know how to give this a common name. only be able to give this a systematic name. So let's start with the first one. Let's name it as, I don't know, let's do the common name first. We have a cyclopentyl group here. So we have cyclopentyl. Then we have a methyl, and we have a methyl. So we have dimethyl and cyclopentyl. So we'll just put here dimethyl, and I'll erase the other one. So what do? This is going to be a cyclopentyl dimethylamine. And how do we alphabetize them? Well, remember, you ignore prefixes except iso, cyclo, and neo. So we have C and we have M. So this will just be, and I'll write it down here, common name be cyclopentyl. So cyclopentyl dimethylamine. So that's the common way. The the systematic way, they're both accepted by IUPAC. Systematic. The systematic way would be to look at the longest chain first. So this is cyclopentanamine. And then we have an N-methyl here and an N-methyl here. So it would be NN-dimethyl cyclopentanamine. So let's pencil that in. So we've got NN-dimethyl cyclopentanamine. Just like that, NN-dimethyl cyclopentanamine. All right, let's take a look at the next one. The common name, I'm sure you all identified it faster than I could. So the next one, the common name, you have 3 ethyl groups. Not ethyl. That would be funny, but it's not that. It's triethyl. So we would just call that triethylamine. Triethylamine. And that base is actually so commonly used that it has its own acronym. We call it TEA, that triethylamine. If you wanted to give it a systematic name, so systematic, which, I can't imagine why somebody would, because everybody calls it trimethylamine, but you would just say, okay, well, here's your longest carbon chain. So this is an ethanamine, and you would call it N-diethylethanamine. And you can see why we like triethylamine. So you'd call it, let's see here, here's my red pen, N-diethylethanamine. Okay, that's just showing you how it works. But again, I can't imagine the circumstances under which somebody would use that name. So there you go. But it's something we need to know. And the last one, we're only going to use the systematic way of naming this. Our longest chain is 6 carbons, so this is some kind of cyclohexanamine. So we have carbon 1, 2, 3. So this is 3 isopropyl cyclohexanamine. So scribble that in, 3 isopropyl cyclohexanamine. And now we need to identify the stereochemistry at the 2 chiral centers. So it's 1 something and 3 something else. Start with the first one. Could anybody identify the first stereocenter as being R or S? Did anybody identify that one as R or S? Stereocenter at carbon 1. Yeah, absolutely. It's 1S. Yep, perfect. And then for the second one, let me erase all this spinach. Just bear with me here. Let's just pencil in a hydrogen here in the back. So the hydrogen is going to be our lowest priority group. So this will be 4. Then we have, this will be 1, 2, 3. So like this. So we're going in this direction. So that's R. So we have 1S, 3R, 3 isopropyl cyclohexanamine. Is that enough work or what? I think it's more than enough work on naming. Let's try another one. Students seem to like these ones more, and I don't blame them. It's always easier to go from a name to a structure. So let's give these ones here a try. If we wanted to pencil down the structure of tricyclobutylamine. So what do we need? We need a cyclobutyl group first. So let's draw a cyclobutyl. Then we need another cyclobutyl coming off like this. And then we'll have another cyclobutyl coming off like this. So that's tricyclobutylamine. The next one, 2,4-diethylaniline. So let's draw structure of aniline first. So aniline looks like this. Remember that this is assumed to be carbon number 1, the one that has the nitrogen attached to it. Then we have 2,4-diethylaniline. So let's see here. 1, 2, 3, 4. Put an ethyl group here. Put an ethyl group here, like that. And the next one has some stereochemistry in it. Those are always fun. 1R, 2S, 2-methyl-cyclohexanamine. So we've got some kind of cyclohexanamine. Pencil that in here. Then we have 2-methyl-cyclohexanamine. So let's just put our, I always like to draw them on a dash first, and then I'll shade them in if I have to. So let's see. If we have 1R, so that means you'd have to go from 1 to 2 to 3. So that means we have to shade this one in like this. So that's better. And for the second one, we're going 2S. So we go from 1 to 2 to 3. So that's going this way. So that would be R. So we have to shade that one in too. Okay. Oops. Okay, so we have to shade this one in as well. Let's do that. There we go. There we have it. Able to draw all 3 of those compounds. Next section deals with some properties of amines. And this kind of goes back to your general chemistry days a little bit in talking about the molecular geometry of amines. But we're going to get into a little more detail here in organic chemistry and talk about the basicity of amines as well.